Okay, so I am Anis Marzuin from M7029. Today I am going to discuss about a question from KMPk Set B 2022-2023. Okay, so as you can see, this is the question and the answer that I have done. So I'm going to explain how I solve this question, and I'm going to give some tips for you guys to answer this type of question. So this is from chapter 2, matter. Okay, without further ado, let's start to discuss. A hydrogen atom produces a blue line with a wavelength of 486.4 nanometers. Calculate the frequency of this line. Okay, so to calculate the frequency, we just need to substitute the value given into the formula, and we are going to calculate this using calculator. It's just an easy question. So frequency. Okay, so frequency has given formula for frequency. V equals to C over lambda. C is a constant value. So just substitute the value here into this formula and tekan je calculator, and then you just will get 6.17 times with 10 to the power of 14 second. Okay, so for this question, I advise you guys to always put the units, even though it's not a final answer. Yeah, so if you guys didn't remember what is the unit for frequency, then you guys just can cancel out the same unit in the calculation you guys did. So you will get this answer. Okay, so for A2, for Balmer series, the hydrogen atom produced the emission spectrum where electron may transition from higher energy level to its ground state. So we know that Balmer, the end final is 2. So to calculate the electron transition associated with this line, we are going to use this formula. Okay. This formula. Yeah. So just substitute the value given. We have here the constant value as well. RH. RH value is constant, 1.097 times with 10 to the power of 7. Okay, so just just substitute the value here into the formula and just calculate. Okay, we have this one. The value of the wavelength given is in nanometers. To calculate or to substitute into the formula, we need to make sure it is in the SI unit first, which is meter. So just 9 with 10 to the power of negative 9. So the N2, the N2 that we are going to get is 4. N2 equals to 4. So the electron transition is from N equals to 4 to N equals to 2, because we know that electron transition is from higher energy level to lower energy level. So because of this, we're going to get this answer. Yeah. Okay, for the last question for A is 3. Name the series of the line spectrum in which this line is found. Name the series. Okay. Yes. So we already analyze this question here. Blue line equals to visible line. So visible line only for Balmer series. So the answer is Balmer series. That's all. Let's proceed with question B. X is an element with proton number of 21. Write the electronic configuration of X atom. So the question already stated the X atom has 21 proton number. So the electronic configuration would be like this. For question 2, give the sets of quantum numbers for the valence electrons in the X atom. So as you guys can see, the answer, I'm going to explain one by one. Okay, so for the first set, N equals to 4, L equals to 0, M equals to 0, and S equals to positive half. And for the second set, N equals to 4, L equals to 0, M equals to 0, and S equals to negative half. While the third is N equals to 3, L equals to 2, M equals to negative 2, negative 1, 0, 1, and 2, and S equals to positive half. Okay. Why is the S is positive 1 and positive and negative? Why the S is positive half and S equals to negative half for the N equals to 4 quantum numbers? Okay, because of the susunan elektron dalam orbital diagram ni. Okay, so orbital diagram untuk 4s ni kita ada 2 elektron, satu yang ke atas dan satu yang pergi ke bawah. Yang ke atas sudah menunjukkan bahawa S dia sama dengan positif 1/2, and yang ke bawah ni pula menunjukkan S sama dengan negatif 1/2. Okay, and untuk quantum number n equals to 3 ni pula positif 1/2 je, sebab elektron dalam orbital diagram ni cuma ke atas saja. Okay. Okay, untuk yang ketiga, draw a shape of orbital occupied by the highest principal quantum number in X atom. Okay, so as we know, the highest principal quantum number in this X atom is 4. So the orbital is 4s. 4s orbital is spherical shape. So the shape will be like this. Like this. Don't forget to label it 4s. Okay, and you got mark here. One mark, and one mark. Okay. Ini cuma untuk kita explain je, no marks given here, okay, no marks given here, no marks given, no marks given, no marks given. Marks only given for these 3 answers only, okay. This is for the explanation only, okay, so one mark here as well. So for the fourth question, write the orbital diagram of the most stable ion for X. Okay, please take note on this question, it said that ion for X, not X atom. Make sure you guys did the right electronic configuration before start to draw the orbital write the orbital diagram, okay. This is the step that I always follow whenever I answer this question. I write the electronic configuration in the SPDF notation first, and then I will proceed to write the orbital diagram. Okay, so when ion, okay, we can see that X atom has 3 valence electron. This is the valence shell. Okay, the valence shell has 3 valence electrons, so the tendency on donating is more than the tendency on accepting. So X atom donate 3 electrons instead of receive more electron to achieve the octet or noble gas configuration. Yeah, macam ni lah. Okay, kalau dia boleh donate 3, which is bilangan yang lagi sikit kan, kalau dia boleh donate 3 elektron, kenapa dia nak accept banyak? Lagi baik kalau dia donate benda tu. Bila dia donate, then dia akan jadi positif ion. So the ion will be X3+. Okay, macam tu lah. Donate kan benda baik, so dia jadi positif. Kalau accept, dia akan jadi negatif. Tapi dalam kes ni, dia positif lah sebab dia donate. Okay, macam saya cakap, kalau dia boleh donate, kenapa dia nak accept? Lagi bagus kalau dia donate yang sikit tu untuk achieve octet or noble gas configuration, rather than accepting lagi elektron untuk capai noble gas configuration tu. Faham tak? Macam tu lah. Donate baik, so dia positif, okay? So akan jadi macam ni lah. And then ada punya SPDF notation 1s2, 2s2, 2p6, 3s2 and 3p6. And then orbital diagram ni akan jadi macam ni. Betul? Lepas satu. Here's a pro tip for you untuk jawab soalan ni. Okay, so kalau nak lukis orbital diagram, kita kena take note dekat Hans rule. Hans rule ni maksudnya macam kalau kita nak fill kan kotak-kotak ni, kotak-kotak 3p, kotak-kotak mana je lah untuk orbital diagram ni, kena follow Hans rule. Hans rule tu macam mana? Okay, Hans rule tu dia cakap kita kena lukis anak panah elektron tu down, upward first and then followed by downward. Macam mana tu? Macam ni. Okay, let's say ni kotak 3p. Ni contoh je tau, jangan get confused with the answer. Jawapan dia kat atas tu dah betul dah. Yang bawah ni just contoh. Dia katakan 3p orbital ada 3 elektron. Cara betul dia adalah ikut Hans rule macam ni. Ada 3 elektron. Cara yang salah pula, kalau korang buat macam ni. Ni automatik ni salah. Jangan buat benda salah, okey? Ada yang salah. Ni yang betul. Ada markah. Ni yang betul. So, hope you guys understand my explanation well. Thank you so much for watching and see you guys in my next explanation video. Bye bye.